So, okay. So, once again, good evening and welcome to the live session number 10 for the course Affective Computing. Um, Today, we will be covering week 10's content, which is based on emotionally intelligent machines, the challenges, and the opportunities involved. So, again, this will be a problem solving and discussion session as per the previous sessions. So let's start, and I hope that you will try to answer the questions. And if you want to, I would encourage you to write the answers in the chat box, and then I think we should move on to the discussion part. So, question number one. Learners' experiences with affective learning technologies involve both the emotions they experience and the improvements in learning gained from their interaction. True or false? So, moving on to the explanation, whenever we talk about the affective computing in learning, so out of many applications which are there for the affective computing, learning is also one of the areas where this can help us. So we have different tutor systems, tutorials, but whenever we talk about tutorials, mostly we talk about the videos that are there on YouTube. You just watch those videos for your reference, or you are attending some kind of live session. So let's say I'm taking this tutorial session and I want to know how much involvement is there from the students side, and whether they are enjoying the lecture or not. So what we can do is we can tell them to keep the cameras on, and that's how we can obtain their video footage, right? So video footage, and moreover we can analyze the facial expressions, the eye gaze, and these kind of sensing algorithms, sensing methods we can use to obtain a kind of a score, whether the student watching the video or participating in the tutorial is genuinely interested. Does he seem bored? Does he look like he is not understanding anything? So like that we can use effective computing in that scenario. Similarly, for let's say you're preparing for some interview and you want some kind of assistant. So you want some kind of assistant which can help you to become better at this being like interviewed, because let's say so many people have social anxiety, or even sometimes you feel ashamed of asking questions in your class, thinking that this is a stupid question. What if the others will think that, oh, he doesn't know this? So many factors are there. As being a student, we don't want to ask questions. So in these scenarios where you can be an introvert or you have some kind of social anxiety, so these systems can be very helpful, because this is just one-on-one interaction, and moreover it's not a human being sitting in front of you. It can be an agent, which can be trained through affective computing. So the agent knows how to respond to your particular your response. So basically they know how to capture the emotions. They can understand what is going on in you, like maybe it's too much for you, too much for the student, so they can reduce the level or difficulty level for the problem that they are saying. So we will see certain examples for this. So let's read this out. Affective learning technologies are designed to consider and respond to the emotional states of learners, enhancing both their emotional and cognitive learning experiences. So yeah, they want to uh, okay, consider and respond to the emotional states of learners. So it enhances their both emotional and cognitive learning experiences. These technologies aim to recognize emotions. Let's say frustration, the person is not able to solve the question, the student is not able to solve the question. So there will be visible signs of frustration on their face, like, why am I not able to solve this? So it helps the system to identify the state of the learner from these cues, and then kind of change your pace or change your response based on the emotional state that you have guessed. So this involves not just the emotions the learner experiences, but also improvements in learning outcomes, let's say comprehension, retention, or problem solving skills. So it is definitely, it will help the person to learn and understand without the fear of judgment, or without, and they can do it on their own pace. So let's say there's an intelligent tutoring system that detects a learner's frustration, may offer additional hints. ठीक है, it boosts their confidence also. So change the difficulty level, maybe lower the difficulty level, or provide motivational feedback that you can pop up a text, say, oh great work, you can do it, etc. So it is motivational, right? So it is motivational, so it helps the to motivate the other person, and it leads to, ultimately leads to the improved learning performance and a more positive emotional experience. If a person, instead of a person, an agent is giving you feedback that okay, um, you need to do work on yourself, but then you're saying it in such a way that it is coming out more like a positive feedback or constructive criticism, you can say. So that's how they are, both are impacted. So I'll just read the question once more. Learners' experiences with affective learning technologies involve both the emotions and the experience and the improvements in learning gained from the interaction. So this statement stands true. Okay. Next question is, sensors, affective learning technologies are typically non intrusive and cost effective, but they can be noisy and lack scalability. Sorry. So, what this means, I think the question means that sensor based, or whenever we are using some kind of sensors in affective learning technologies, then they're typically non intrusive, which is true, because sensors, we use different kind of sensors in the affective tools or technologies, such as cameras. Okay, cameras are there, microphones are there, microphones are there. Physiological sensors, you can say that they are intrusive up to some level. Let's say you are measuring the electrodermal, it's not actually intrusive, it's just plugged on, like put on your fingers to sense. It's not like some needle is injected or so. So yeah, sensors are typically designed, and more and more sensors are being designed to be more like non-intrusive in nature, and they are so that they cause minimal disruption to the learner. It's not like it's very uncomfortable and the person is thinking about the sensor all the time, and it's not even focusing on what the actual task is, and it will defeat the purpose of the experiment. So we want the sensors to be as comfortable, as non-intrusive as possible, and nowadays so many sensors are all available already. But yeah, there are certain challenges such as noisiness and scalability. So noisiness is basically the non-intrusive sensors. There's a trade-off. If a sensor is non-intrusive, and if it like measuring something from a distance, so there are higher chances that the readings might not be the exact, like uh, precise information, or precise readings, but the readings or the approximations will be like more like an approximation and not the correct. The accuracy might be slightly on the lower side. However, there is a trade off, like if you, let's say you want to know my arousal state from electrodermal activity, then it will be uh, like it is, let's say non-intrusive, and let's say I'm figuring some method out which is just looking at me from using camera sensor, and then I'm measuring my arousal state of facial expression. It might not be that accurate every time. So noisiness is also there because the sensors are disturbed, affected by some external factors. Let's say if a camera based sensor is there, my video is being recorded, and let's say the light is not there good, there are bad lighting conditions, so my face will not be captured in detail, like the resolution, the clarity, basically the clarity will be less. So lighting conditions हो गया. In the case of microphone, there might be a background noise. It won't capture your crisp or clear voice. So there can be interference, two sensors, let's say, or maybe in a vicinity of some other electronic gadget, which might have some kind of interference with the electromagnetic fields, or so. And so yeah, the accuracy might be compromised because of this noisiness. Then comes the scalability issue. These sensors are of course expensive as well. They this like in case of some educational setting especially, it can be very difficult to, due to variations in environments and learning behaviors. Moreover, same technology cannot be applied across different contexts and with same effectiveness. So let's say, for example, an eye tracking sensor is there, and it is used to detect engagement in a learning platform. Then the platform may struggle to maintain accuracy because the lighting condition change or the learner moves around too much. So ideal situation is that I am just looking straight into the camera, and the light is very it is well illuminated room, and you can clearly see my expressions. But let's say the light is not that great, and maybe it's the night time, and it's artificial light or very dim light settings, or the camera is not working properly, like it might be physically damaged, so it's not able to capture well. So these factors, it can reduce the accuracy of the system. And maybe I perform a lot of movements while moving my head while talking, so the system won't be able to capture the meaningful, like, features from it that effectively, if my head would have been a stable position. So, and also expanding such a system to a large number of learners, it is very very challenging in terms of cost and infrastructure. So cost is also very important. These sensors are not cheap. Let's say some sensors can be cheap, let's say camera. Nowadays we all have cameras in our smartphones, but let's say thermal camera is there, or any kind of other sensor, let's say EEG sensors or ECG sensors. So these are not scalable, and these are not cheap, so they are very very expensive, and they need a proper setting everywhere. So the correct answer would be they can be noisy and lack scalability. So the correct answer is true. Then comes question number 3. So there are there are different levels of adaptation. We will just discuss in a while. So which level of adaptation in affective computing involves no alteration of the system's behavior in response to users emotional state? So level 0, 1, 2, 3. There are 4 levels basically. Actually there are 5, but then let's just discuss about these 4. So there are different levels of adaptation. So what do you mean by levels of adaptation, and in what context? So it refers to how systems respond to users' emotional states. Let's say we have an affective system. Let's say we have a robot, and you are interacting with that robot, and you want that whether like the robot is adjusting its response based on what you are feeling or your response. Then there are so many there are 4 to 5 levels of adaptation. So based on how much it can change, how much it can provide you dynamic responses. So the range this is from 0 to 4, 0 to 3 actually. Okay, so these levels describe different degrees of system responsiveness to the detected emotions, ranging from no response to dynamic real-time adjustments. So there are basically 4 levels of adaptation. So let's discuss about level 0 here. So talking about level 0 adaptation, that means it is very static. So very 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 static. uh, this is the most basic level. most basic level, where the system detects emotions but it does not alter its responses or behavior based on this information. Let's say there's a video tutorial system and it continues to present content. So it continues to present the tutorial regardless of whether the learner is feeling tired or confused or bored. Let's say you also are capturing the video, but then you can sense that the student is not able to understand, but then you're doing nothing about it and you're just playing the video at the same pace. No changes are made to the system's interface, or no changes are made in the presentation style. By presentation style we mean, let's say, the pace or difficulty level. Okay, so these kind of changes we can do. Now comes the second level of adaptation, which is level 1. At this level, the system responds. Previously, it was doing nothing. Now, it responds to predefined emotional triggers with pre programmed actions or responses. So, let's say you detect boredom. Now, it is more like a rule based. Then the system has been programmed in a way, then when it detects boredom, then you have to do this. This is a fixed response in response to your emotion. So let's say a customer chatbot is there that recognizes frustration in a user's language, and then it triggers a generic calming response like, I understand you're upset, how can I assist you better. So it is knowing that the person is getting frustrated, that I am trying so for since so many days for my refund and I did not get. Now the chatbot can sense that you are very upset about it and you are very frustrated about it, but then it acknowledges the fact. So acknowledgement is there, like it can acknowledge that uh, that there is something, emotion is being expressed, and it acknowledges that, okay, I understand that you are feeling this way, but it won't do anything except for those predefined responses. So it can just show you this message. So ultimately it is relatively static and non personalized. It is not personalized to, like, it is it will generate the same response for me for any other person in this particular situation. Then comes level 2 adaptation. So it involves dynamic adjustments to the system's behavior. So how will it decide? It is based on detected emotions. It provides a more personalized user experience. Now the system modifies its responses or content in real time according to emotional inputs. Okay, so let's say an example is an intelligent tutorial system which detects that a student is confused. Okay, maybe I'm scratching my head and then it can sense that the student is confused. Okay, and it then what it does is slows down the pace of teaching, offering more detailed explanations. As say we discussed here, that presentation style can be changed, or it can change the interface, like let's say font size can be increased, or the visualizations can be included and some messages can pop up. So many possibilities, but it can do that. Now comes the fourth level, which is level 3. The system is highly adaptive and it can continuously adjust to real time emotional feedback. So more like a real time system. The previous one is dynamic, but it is the USP is, so this is more like a dynamic system, and this is personalized. Okay, and in level 1 it was acknowledgement was there, then it was predefined responses. This is personalized responses, and in this case this is more like a real time dynamic. So it anticipates the user's need and optimizes the interaction process on an ongoing basis. So it is more personalized and engaging experience, sorry, engaging experience. So let's say a virtual reality training program is there, which detects both physiological and facial expressions, and then it can adjust the difficulty level of tasks, and provides encouragement or relaxation exercises as needed. So this is more personalized. Although this is also personalized, but then this is more like a real time and deeply uh, personalized. Then, just to summarize these levels, so level 0 means no adaptation based on emotional state, and it is useful in very simple systems where we do not require any kind of emotional adjustments. So use simple systems, okay? Then comes the level 1. There are predefined responses based on detected emotions. It is not deeply personalized. It introduces basic responsiveness suitable for systems like chatbots or scripted virtual agents. Now level 2 is it is more of a real time dynamic adjustments to personalize the user experience. This is continuous as well, so real time adaptations for it is highly personalized, and for interaction and engagement. So so both level 2 and 3 are offering more advanced emotional interaction because they are providing us personalized responses, and it is very valuable in the field of education, mental health support, or customer service, where adapting to the this emotion is very much desired. So yeah, this is level 0 in this case because no alteration was asked. So level 0, it means no alteration. Then next question is, at level 2 adaptation, no actual adaptation takes place, but the system can recognize the necessity for adaptation. Is this true or false? We just read that this is false. Why? Because level 2 means uh, adaptation, and it is personalized. But level 1 is basically it can acknowledge, or it can um, know or recognize the necessity, that I understand you're frustrated, but then what will it do nothing, so does not act. So the correct answer would have been level 1. So this is not true for level 2. Okay, camera can be applied to monitor the heart rate of the user. So it seems very vague, and it seems that this is not possible, but we have a technology which uses camera based heart rate monitoring. So it is called as a remote PPG, which is remote photo plethysmography. So let's see how it works. First of all, it is a non-intrusive method, and it uses a standard camera. So we do not need any expert system for it. We don't need any specific or special system sensor for it. So it can any standard camera can be used to detect subtle color changes. So there are very so many, like the blood is pumping, and the heart pumps the blood and it goes through the this nerve, this veins, right? So this uh, sorry, it can cause slight variations in the skin tone, especially in areas like the face, especially in this cheek region. You will find slight differences when the blood supply is more, and then it will turn to more pale when the blood supply is not there. So you can detect how much the color is changing, but this is of course by naked eye it is difficult to observe, but these camera based sensors, we can this technique we can use this, and researchers have proposed this method. So uh, by analyzing the changes in the captured video frame, so it will capture your video, and the system can estimate how many times that it is changing in a minute, let's say. So the amount of because if blood supply is higher, then that means one, it will be counted as one. So more red is one, and how many times it turns red, more red than the pale one. So that is how we can obtain the count of how many times the blood is pumping, and similarly we can calculate the heart rate. So again, as the blood flows through the body, it causes slight variations in skin color, especially in areas like face and especially on the cheek region. These variations are often invisible to naked eye again, but then it can be detected using a camera with image processing algorithms. Use cases are it is used in healthcare monitoring, although it is not the best way to measure it, because but sometimes we need non-intrusive methods, and sometimes we need let's say it might not be as accurate as the ECG, but then if it is providing us good approximation, we are fine with it. Okay, fitness tracking apps, let's say there are so many camera based, maybe app based, some sensing is going on. So smart watches or smart phones, they can have some fitness apps, so you can just need to just look into the camera and it will capture your video, and that's how it can estimate. So where no contact measurements are preferred, then we can use these methods. So in this picture you can see that especially the uh, this ROI detection, firstly we are just obtaining the facial region, and then if you look at it, skin segmentation is there. We don't want to consider the eye region, so only skin is considered. So it has blurred out the eye region here. And then you want to obtain the color. Let's say the cheek region is specifically more red when the supply is more, so it can extract the RGB components, and then we can identify the number of this pulse rate and so on. So it can give us an idea. So this statement is true. Okay. So question 6 is, cognitive empathy involves perceiving the emotions of the target in a logical manner. True or false? So what is cognitive empathy? We talk about two kind of empathy here. Okay, only one. Okay, cognitive empathy, it involves understanding. It is very important, understanding and perceiving others emotional state in a logical and intellectual way. So cognitive means thinking, so it means to think, and to think means logic. Okay, so we uh, respond to something when we think about it, and we, in case of empathy, we know that the other person is feeling like this particular emotion. So but then we also understand and perceive others emotional state in a logical and intellectual way. We want to know the reasons behind how the person might be feeling like that. So other one is emotional empathy. Emotional empathy means directly feeling another person's emotions. Let's say I'm happy, I'm laughing, and then you come to meet me, and then you also feel happy. It is more like an induced emotion in your case. So like that. But in case of cognitive, we do not want to feel the same emotion, but we understand that why this is happening to the other person. So let's say this emotional, unlike emotional empathy which involves directly feeling other person's emotions, cognitive empathy is about recognizing and understanding, like what someone else might be feeling or thinking, without necessarily sharing those emotions. This is I think the most important thing, without necessarily sharing those emotions. So this is important differentiating factor. We don't, it's not like I, if I'm looking at you, you are sad, then I might not feel sad, but then I acknowledge the fact that okay, you are feeling sad, and why would you be sad, and the reason and everything. So I think about it. This is understandable in the context of a therapist. If you go to a therapist, then they don't, like, if you are crying, then they won't start crying with you, but they understand that why this is happening, and they will probably tell you to vent out. So they use cognitive empathy to understand a client's emotions intellectually, while maintaining enough distance to offer clear or objective advice without becoming emotionally overwhelmed themselves. So this is correct. Perceiving in a logical manner. Okay, so this is correct. Okay, failing to distinguish between categorical and continuous models of emotions leads to challenging challenges in generalizing machine learning algorithms. So, as we know, the emotions can be represented using two models. One is categorical and other one is continuous model. So, categorical model, what they tell us is different categories are there, predefined categories of joy, sadness, anger, disgust. Like we have six standard this classes. So, but on the other hand, the continuous models, they provide us some kind of numerical value, because mostly the system, the computer understands the numerical value more. It is more interpretable for the computer, and it can represent any kind of emotion with different intensities as well. Let's say happiness is just, it's not just one point, but um, it is a, like, we can also represent happiness with different intensities. Let's say more happy, happiness with calm. So so many categories are there. It's not a discrete category, but it is more on the continuous side. Okay, so they focus in how emotions vary in intensities, and quality over time, rather than fitting into distinct categories. So conflating the two can lead to problem. Now if we mix up these two, let's say one model is there, one machine learning model is there, it is trained on categorical model. Now you want to predict the dimensional, in the terms of dimensional model, let's say continuous value. Of course it's not going to work, because the labels or the type of problem. So in this case, the problem will be more of a classification problem. However, in the case of continuous model, it is more of a regression problem. So you cannot mix the problem. Although the content or the, the characteristics are learned might be very similar, because ultimately the problem is same, but then it might not be that accurate if we are using it cross these models. um, so algorithms may not be able to understand or accurately learn from the data if the underlying model is, if the underlying emotional structure is not understood. So basically, let's say the difference would lie between, there are, this is like happy, and let's say this is relaxed. So if we talk about the dimensional model, these two are different entities. However, in the case of, this is categorical, and in the case of discrete, so this will be happy, sad, angry. So relaxation, and this will be overlapping. So this will be overlapping, and that's how, if you want to use categorical, this is not categorical, actually this is categorical. Yeah, this is categorical, and this is dimensional. So if we want to use dimensional on in terms of numbers, valence or arousal, this is valence, this is arousal axis. So then you should also train your model on this dimensional model itself, because cross two models it won't be giving you good results. So generalization becomes difficult if one model which is trained on a different type of representation is tried to use for uh, different model or different problem actually. So let's say if a machine learning model is trained to classify into specific categories like happy or sad, but then it is later applied to a situation when we want to assign number, how much intensity is also there, then the model may struggle to produce accurate or meaningful results. So failing to distinguish emotional leads to challenges in generalizing, definitely yes, because we want the suitable training and testing match happening. Okay, which of the following are the ways individuals may respond empathetically? So there are types of empathies that we can express. Now, there are two kinds of these empathy. One is reactive and other is parallel. Now, which of the following are the ways individual may respond empathetically? So, are these two valid empathy types or not? So, types of empathy. First one is reactive empathy. Reactive means to react in response to other person's emotional state. So, this is when an individual responds to another's emotions with an emotional reaction of their own. So responding with an emotional reaction of their own. This empathetic person recognizes and responds to the emotions of others, often with support or comfort. It involves understanding the other person's emotional state and reacting accordingly. Let's say offering comforting words to someone who is sad. For example, a person sees a friend in distress, and then the reaction will be offering a hug or words of encouragement. The emotion of empathy is triggered in response to seeing other person's emotional state. Then it is the reactive empathy. Then comes the parallel empathy. Parallel empathy is, that means you are reacting with something like which is very similar to what the other person is experiencing, it to mirror the emotional state of other person. Like in this case, the reaction might be different. uh, let's say if the person other is sad, then you can respond by maybe becoming giving them, maybe comforting them with a hug or so, right? But in this case, in parallel empathy, um, we reciprocate the same emotional state. So instead of reacting to the emotions of others, they begin to experience similar feelings themselves. It involves sharing the same emotional experience as the other person. If someone sees a loved one feeling excited about a good news, then we will also feel excited. Even the news is not affecting me directly, but if the person is like jumping with joy, then I will be very very happy. So that's how it works. So person is paralleling the emotion of excitement in this particular case. So there are both are legitimate ways in how we can respond. Depends on the situation, basically what kind of emotion is being expressed and how we should react to it. Okay, which of the following best describes a process that involves considering or perceiving the emotions of target more emotionally or in a natural way? So, cognitive empathy is there or affective empathy? Both A and B or none. Similarly, there are two more categories which are based on, like, do you think cognitive? We saw that cognitive relates to the thinking process. We want to sound more logical. We want logic. We want to find the logic or the reasoning behind anything. So cognitive, that means we try to find the reason why the other person is behaving that way or feeling that way. So cognitive empathy, it involves understanding the emotions in a more intellectual or logical manner. It is about recognizing what the other person is feeling and understanding their emotional state. It does not necessarily involve experiencing the emotions oneself. Same in the case of therapist, right? A example for this is, a person recognizes their friend is upset and failed for the exam, but then they understand that he has failed, so that is why the disappointment and frustration is there. So it does not necessarily mean that I will also experience the same thing, because I am not directly related to that. But then next is affective empathy. It means actually we are sharing the emotion. So it is more like a reactive versus parallel. But in case of this, cognitive is basically, uh, you can say, different meanings or different classification criteria, but still you can slightly say that affective means sharing or feeling the emotions that the other person is experiencing. So it definitely involves an emotional response to another's emotional state. So let's say when you're seeing somebody who's crying, you also feel sad. You're not just recognizing the sadness, but you're also experiencing the same thing. So you're also feeling it. So in this case, the question was, which of the following best describes a process that involves considering or perceiving the emotions more emotionally or in a natural way? So this is affective. Cognitive means more logical. Okay. Which of the following best describes the factors influencing emotional responses in empathizers? The empathizers: astrological sign, political affiliation, personality type, gender, age, and mood, then favorite color. All of the other options are literally, they don't make any sense. So, correct option is option C, because these factors definitely influence how the emotional responses will be framed. So in empathizers, which are affective systems which can empathize with you, which are aware of they are more empathetic. So they can be influenced by several psychological and individual factors. Here we are going to discuss about these individual factors more. So basically depends on how my personality is and your personality is, the emotional agent should modify or adapt the responses according to what person they are talking to, or what their person they are like interacting with. So first is personality type. Let's say whether they are more introverted or extroverted. If agreeable or disagreeable can influence how they respond emotionally to others. Let's say I always agree to somebody's whatever somebody's saying, so I'm mostly like, oh yeah, yeah, I agree to this statement. uh, so it shows that you're more on the open mindedness. You have that characteristic in you. Or and an empathetic person is usually considered like agreeableness, and it is likely to respond more emotionally and supportively to someone in distress. So a person who is highly empathetic may feel strongly for someone who is sad, right? Strongly, and may be inclined to offer support as well, whereas a person with lower empathy might not feel as much as emotion in the same situation. And same goes for gender. Let's say women might be more likely to share the emotional pain of a friend than a man might be, because depending on the cultural context, expectations, and personal emotion expression. Then comes the age factor. A teenager might feel overwhelmed by a friend's distress, but then adult knows how to respond to it with more of a calm response and understanding and advice. Then mood. If a person is feeling anxious, they might not notice that the friend's sadness, or because they're busy with their own problems. So I won't pay attention to my friend's problem probably when I am more stressed or I'm not doing well. But if I'm fine, I'm doing neutral, or even happiness is there, I am more likely to notice the other person's emotional state because I am more stable right now. So that's why. So the correct answer is definitely C. Okay. Then Moore's law is related to speed of operations in electronic devices, power ratings of electronic devices, levels of integration in electronic devices, price of electronic devices. So Moore's law was basically, it refers to the observation made by Gordon Moore, the co-founder of Intel Corporation. So in 1965, just factual information. So what it predicts is that the number of transistors on a microchip will double approximately every 2 years, because we are progressing towards more and more powerful chips, more efficient chips. Even the size is becoming smaller, but then the number of transistors on a microchip, they are increasing. And more predicted that it will double every approximately every 2 years. The number of transistors will be doubling. So this observation has helped remarkably true over several decades and becomes a kind of a guiding principle for semiconductor industry. So it focuses on increasing transistor density. It also tends to result in cost reductions for electronic components over time. And as advancements are there and mass production is there, the unit is decreasing, the unit cost of the sensors is decreasing, then the cost reduction makes sensors more accessible for widespread deployment across different industries, applications. Even the smartphones, everything are so much more cheaper and accessible to all of us. This is because of the revolution in the semiconductor industry. So the level of integration, he predicted that it will be more, it will increase. And then yeah. So next question is, experience during interaction with effective learning technology is subject to higher variability among learners. So definitely yes, because in real life scenarios, what happens is no two people are alike. There might be broad categories, but then every person is different. They have their own uh, set of characteristics, behavioral characteristics, even emotional characteristics. So there is a high variability among the learners. So in how do affective systems are like affected by it? It is uh, yeah, there are so many factors because of which these systems experience it. First of all, individual differences. So firstly, like cognitive abilities are different, learning styles are different, preferences are different, and emotional states are different. So yeah, their experience with effective learning might be different, it is actually different for everyone. Then emotional responses, then affective technology, it aims to adapt to learners emotional states and responses, we know that. However, individuals may react differently to the same stimuli or even interventions. Let's say I'm telling you, I'm popping up that you can do it, you can do it, and it is popping on the screen that good going, you scored good marks. After every question, the system is trying to motivate you and send some motivational quotes. But then let's say I am somebody with very short temper, so I might get frustrated very soon, like why is this displaying every time? But on the other hand, let's say one person is there who are very underconfident about themselves, but after every question they're solving, they're getting the same response, um, that you're doing amazing, keep going, etc. And for that person, it might be motivational. So that's how it totally depends on and the user, the characteristics of the user, engagement levels, etc. These factors, context also, um, then we can only decide like how well the system is performing, but it's very subjective thing. Also, this is based on motivation, interest in the subject. Let's say I'm not even interested in economics, so I would be very bored learning that subject. But let's say it is affective computing and I'm very much interested, so it will be more interesting for me and I will be more involved in the conversation. Similarly, the contextual factors are the learning environment, social interactions, external distractions can impact learners' experiences. So you cannot say that if my experience was good, then the other person experience will also be good. So yeah, so this is true. It is subject to higher variability among the learners. Okay, auto tutor is one of the first reactive conversational intelligent tutoring systems. Reactive means, okay, reactive means it can react accordingly. Conversational means that it is more like we're talking to a intelligent system which can respond in a more naturalistic way. Intelligent means it knows the logic, everything. And tutoring system, so for any subject, this particular was for one subject. And so the question is around the auto tutor system. It was the first reactive conversational intelligent tutoring systems which can detect boredom and confusion but not frustration. So it is an intelligent tutoring system definitely, and helps students to compose explanations of difficult topics in Newtonian physics. Now it enhances the computer literacy, basically how to operate computer, then critical thinking by interacting with them in a more natural language, like chat gpt or talking to chat gpt. It responds in a natural language rather than the predefined responses, with adaptive dialogue moves similar to those of human tutors, right? So auto tutors construct a cognitive model of students knowledge by, so basically by analyzing the text, their typed or spoken responses. So it will create one kind of profile for me based on my responses, like okay, Akanksha is able to understand this well, but she lacks somewhere in the maths. So it knows what I am good at, what I am bad at, or how am I responding, how expressive I am, etc. So it dynamically tailors the interaction towards individual students' zones of proximal development. So basically, effective auto tutor takes the individualized instruction and human-like interactivity to a new level, and it helps to detect and respond to emotional states of students in addition to their cognitive states. So it uses a decision level fusion where each channel, conversational cues, face, and posture independently provides its own diagnosis of the student's affective state. So decision level fusion means that after processing each modality individually, we are just combining the results to obtain the final decision. These individual diagnoses are combined with an algorithm that selects a single affective state and confidence value for the detection, and it can sense frustration also. So the statement, so okay, look at this diagram. This person is the student or the learner, then this is a system. You see there is a agent with this is a smart virtual agent, and this is a camera sensor, so the camera is capturing the face, and this is the physiological or posture measurement system. So then this is eye tracking is also there, template matching, etc. And this is taking logs of whatever you are doing. So many modalities are there. So it can definitely, it can detect the frustration. That is why this is a false statement, because it is saying not frustration, but we know that it can. Another example of these effective learning systems is the gaze tutor. So, Gaze Tutor is a multimedia interface which is consisting of an animated CA. This statement is true or false? So, Gaze Tutor is basically an intelligent Gaze Tutor is an intelligent tutoring system, which is ITS, the short form, and it aims to promote engagement and learning by dynamically detecting and responding to students' boredom and disengagement. So it uses the gaze as well. So if you are not interested at something, you might look away, so my gaze direction becomes deviated from the screen. That's when it uses a commercial eye tracker and monitors the student's gaze patterns and identify when the student is bored, disengaged, or is zoning out. The tutor then attempts to re engage the student with dialogue moves that direct the student to reorient attentional patterns towards the animated pedagogical agent embodying the tutor. So basically, there's an agent which is more like a virtual avatar. So every time you feel bored, let's say I started looking, there might be something popping up on my screen so that it grabs my attention and the system it gains my attention back. So something like this. It is just saying something, the video is playing, and this is a responsive entry of, maybe I need to add the maybe I need to enter the option number or choice or whatever. So this is a snapshot. So multimedia interfacing consisting of an animated CA. This is false. There is no animated character. Okay. This is your. This is basically your video is being captured. Then level 0 adaptation systems recognize that the performance of a particular task could be optimized according to some metric, but no adaptation is performed. Level 0 does not even acknowledge it. We have seen that, let's say traditional vending machines, it is just going to do what it does for everyone without any anything that like it has nothing to do with your emotional state, it is not even analyzing it. Similarly, if there is an intelligent tutoring system, then it is recognizing, or let's say chatbot, it is recognizing that okay, the person seems frustrated, or here in the case, let's say if it is detecting a student is frustrated but it is still not adjusting the lesson plan, then it is also level 1. Then level 2 is single task adaptation, which means that a single task within the system is adapted to optimize a performance metric. Let's say conversational AI agent, and it responds is to maintain a positive emotional state. If you sense the frustration, then you can message me with a very good uh, positive message that you don't have to worry. Let's say you don't have to worry, and you the problem will be sorted really soon, please, if I can assist you in any way. So these kind of comforting words can be there. Then comes the multitask adaptation. This is the level 3, when multiple tasks are optimized. Let's say, and there is a tutor adaptive learning platform, and it rearranges the lesson content and pace both. Like, not only just the content is being adjusted, the pace is being also being adjusted. So this is level 3. And then comes the level 4 that I was talking about before. The level 4 is basically multi agent communication and adaptation. Let's say a multiplayer video game is there. Different characters adapt their behaviors and interaction based on the emotional state of the players, coordinating to provide a more cohesive and engaging experience. So, in the above levels, only one agent was in picture, one agent. Here we have multiple. Okay, so this is the difference. So in this case, level 0, it does nothing. So basically, it is false. This is the description for level 1. Okay, affective states can be monitored using behavioral data, sensor data, A only, B only, both A and B. So, behavioral data is basically how you are behaving in response to something, and sensor data is just more like a quantitative measure of what you're feeling. So, behavioral is more of a qualitative, what you can observe by looking at the person or observing the body posture, the body movements, etc. So, observable actions and responses that indicate an individual's emotional state. So, this is the behavioral data. Example, in a gaming, if the person starts smiling and laughing while playing, that means maybe they are winning or they are experiencing some kind of positive emotions or joy or excitement, right? If a student is becoming visibly frustrated or agitated, then that means they are trying to solve a problem, it's not being solved, or they are experiencing some kind of negative emotion, right? Then the sensor data. Sensor data is maybe also from the camera sensor or from the physiological sensing. Let's say heart rate variability, ECG, EEG, skin conductance, and facial expressions also to estimate the emotional responses. Now, in case of fitness tracker, let's say you're watching, you have a smartwatch and they're wearing it, and during a workout, if the wearer's heart rate is increased, it can tell you that the person is feeling exerted or determined, or emotional state can be captured, or maybe tired also. So similarly, the facial recognition can tell us the frowns, smiles, and raised eyebrows, providing insights into users emotional state. So yeah, both A and B are true, they are correct. So affective states can be monitored using both. Affect detection generalization is a very challenging problem because there is inter-user heterogeneity, which is true. We just saw that this inter-user heterogeneity, that means difference between different users. User 1 is different, and so user 1 is different from user 2. So this is inter-user heterogeneity. Now it refers to the variability or differences among individuals in how they express and experience emotions, and this variability can manifest in different ways. Let's say differences in personality traits. I'm more of an extrovert and the other person is introvert. Cultural backgrounds, I come from India, you come from US. Past experiences, let's say I don't have a good experience with dogs, but you love dogs. And physiological responses. So, detecting and generalizing affective state, it's not that easy, and it becomes very challenging because for me, something is happiness, the other person might not find it happy state. So, it is very difficult to generalize. Okay, so there is an example to understand it better. Imagine a scenario where an effective learning system is there, and it is designed to detect students' engagement levels during an online lecture. So it relies on facial expressions, body language, and physiological signals, right? Uh, it encounters challenges due to inter-user heterogeneity. That means facial expressions. Let's say some students may display subtle facial cues when they are engaged, such as slight smiles or nods, while others may exhibit more pronounced expressions. So I personally like, I nod my head a lot of time whenever I'm agreeing to some teachers whatever they are teaching us. But some of my friends might not do that. They will just sit and observe what is going on. So cultural differences also play a part. It can also influence facial expressions. Let's say there's a typical notion that men usually don't smile that much as women do. So in some cultures they are not considered to be more expressive. A student from a culture that values restraint and composure may not display facial expressions when fully engaged. Then comes the body language. It can also significantly vary. Some students may lean forward, make frequent gestures while actively participating, but another may prefer to sit back and listen and attentively without much movement. So for the same stimulus, basically there are different responses from every other student. Also physiological, a student is who is physically fit may have lower HRV, or heart rate, sorry, as compared to the sedentary student, making it challenging to establish the universal thresholds. Then the cognitive factors are also there. One person might be very you know uh, they can catch the concepts really well, really fast, but then one person might be very slow in processing what is being taught, and then they will understand. So also concentration and engagement, uh, so these factors are always there. So effect detection generalization is a very difficult task because of the inter-user heterogeneity. So shimmy is an example of level 2 adaptation. True or false? So if you talk about shimmy we saw in the last lecture, or I think last to last lecture, when we were talking about the intelligent agents. Shimmy is a robot which is basically a music companion. So it, whenever you play a song, let's say I want to play a sad song, so if it starts with that, you can dock the mobile phone over there, and then it can listen to the song and produce some similar songs. So that means it is it is capturing, it is understanding the emotional content, or the emotional state which is being expressed in the song that you played. And then it can also tap on the table accordingly, according to the beat or the tempo of the song, and it can also play some similar songs. So is it level 2? So the characteristics include, it is designed to enhance a human's music listening experience by providing social presence, audience companionship, and it serves as both as an amplified speaker dog and socially expressive robot. So this is true because, as I mentioned, it is also sensing and responding accordingly. Similar songs and taps on the table based on tempo or like beat. ठीक है. So, understanding a player's affective profile will not help in enhancing the computer game experience, which is false, because if we know what kind of a personality the person is having, then we can customize the game playing experience for that person. So, yeah, the first point itself is personalized gameplay, which means if we know about the profile, then the game developers can personalize experience to match the player's emotional preferences. Let's say if the player enjoys challenges and in competition, if you are open to explore different challenges, also to take part in challenges, and you're not afraid of those challenges, which is your personality trait, right? So the game can dynamically increase the difficulty level so that it keeps you engaged. Let's say I get very bored when I'm playing the same, okay, this is the same type of game I've been playing since past 1 hour, and I there is nothing new in the next level. But if the the system knows that you like more challenges, and it will create a more challenging next level for you. However, if I get overwhelmed, like this game is too difficult for me to play, and I want to just slowly gradually increase the difficulty level, and also the game can adjust accordingly. So adaptive, it is definitely a personalized gameplay can be there. Adaptive challenges are that Yeah, I mean, basically the same thing, that affective profiling allows game systems to adaptively adjust the game's challenges, right? If the system is observing that there is frustration or boredom, then you can decrease the difficulty level or offer hints, etc., to keep them engaged, right? Conversely, if the excitement or engagement is there, then the system can introduce more challenges or puzzles to maintain players' interest. Same for the tailored feedback and rewards, dynamic storytelling, and also they're creating immersive environments. So uh, if it is there, like let's say I like ambient music and I'm more of a calm person, then I would love this ambient music, even lighting effects and so on. So the statement says that it will not help, although it will help, so the statement is false. This question we've already encountered once. So cameras can be used to monitor the heart rate of a user. Yes, we know the technique is called RPPG, which is the remote photoplethysmography, right? And subtle changes in the skin color caused by variations in blood volume in the microvascular bed of skin, which occur with each heartbeat, right? By capturing videos of user face, particularly regions with good blood perfusion, such as the forehead or the cheeks, right? And using specialized algorithm to analyze these color changes, it is possible to extract the heart rate non-invasively. So the USP is here, non-invasiveness. And this is the again this is the same picture, so the statement is true. Okay, how many modalities does the affective auto tutor system track to detect users' emotional state? So we saw that in the affective auto tutor system, we saw that there was one modality which was the posture, right? And another was the facial expressions, and third is interaction patterns, the way you respond. So there are basically three modalities. So first is facial expression, speech, and interaction patterns. This is we saw that this is the body language, this is the contextual cues, this is a camera, and this is the facial features here, right? So there are three modalities involved. Okay, next question is, what is the primary objective of gaze tutor system? To track users' emotional states, to monitor users' attention and provide interventions, to display multimedia content for educational purposes, to analyze users' body language during interaction. So, Gaze Tutor is basically again an intelligent tutoring system. It aims to promote engagement and learning by dynamically detecting and responding to students' boredom and disengagement. As we saw in the picture as well, that if I'm not, if I seem to be disinterested, then it might pop up something like a message or so, um, which can like which can help me to bring my attention back to the this video that is going, like the tutorial basically. So it uses a commercial eye tracker to monitor students gaze patterns. Then we know that whenever the student is bored, disengaged, or zoning out, so it attempts to re-engage the student with dialogue moves, that the student to reorient his or her attentional patterns towards the animated pedagogical agent embodying the tutor. So it observed that the gaze reactivity uh, positively influenced learning gains, particularly at deeper levels of comprehension. Basically, the gaze is very important measure to understand the involvement of a person in a particular situation, because if you're looking at it, there are high chances that you are invested in that. So this discovery of a medium-sized deep learning effect with gaze reactive, it provides a major advantage. So we know that this is how it works. So student is there. Firstly, it will also enter the text or responses. Then the gaze is captured, gaze is assessed. If gaze statement is there, if you see like it is fine, then it is like the tutor output is there. There's a feedback module as well. Feedback will also tell the tutor will give you this output. Similarly, there is tutor question as well, so there is script. So there are these components for the gaze tutor, but the ultimate goal is to monitor the attention and provide interventions. Okay, what challenge arises when incorporating context and appraisals into affective computing models? Uh, Lack of sensor availability, difficulty in modeling, cultural differences, transient emotions. First option is not correct, because sensors can be acquired. It is solvable problem, but the main problem lies when we talked already about the inter user heterogeneity or differences. So different contexts and different appraisals, when we want to include that information in the effective computing models, we like it is so diverse that it is very difficult to understand the objective definition of a concept. Let's say in this context, also appraisal refers to the cognitive process through which the individuals evaluate situations. So basically how you can process uh, by thinking about the problem, or what do you need, how do you come up to the solution. That is the word appraisal is referring to here. So let's say if a player in a computer game perceives a particular game as challenging but achievable, appraisal of controllability, compatibility with goals, they might experience excitement. But if they perceive the level as overwhelming and impossible to conquer, then it might be frustrating or even anxiety. So these two different context information and appraisal information, they provide different roles in shaping the emotions, but then can also introduce complexity in modeling, because what happens is the data is like everything. So data, to train a ml model or a dl model, we need more and more data. And if it is having so much variability, then the looking for those patterns is very very difficult. If, in other words, in a simple example, let's say I tell a system that if you see a smiling face, then that is happy. Now this is a very simple rule. The machine will be will be able to learn this in a very easy manner, right? But if I tell that if a person is smiling, then you have to look around how many people are there, whether the person is in a um, happy situation or a sad situation, or if the person is in a happy situation, then the intent will be happiness. But if, let's say, others are sad or something and the person is smiling, it might be sarcasm, it might be uh, just degrading someone, like that. So it is not happiness. So the context matters a lot. Also, if for me happiness is smiling very wide, but let's say for some person who is an introvert, or they have their own characteristics, they don't like to smile that wide, they just put a small, like, just tiny smile on their face, but still it is the emotion experienced is same, but there is a lot of difference, variation between how the happiness is perceived and expressed. So This is very difficult to model using these ML DL systems, because we need to take a lot of factors in consideration. Okay, so difficult to model. That's why the generalizability is a problem. So uh, these so generalizability is a problem here. How does a level 1 adaptation system differ from a level 0 system? So, it performs adaptations based on emotional states. It monitors emotional states but does not recognize the adaptation, recognizes the need but does not perform. It relies solely on predefined interaction scripts. So, in case of level 0, there is no acknowledgement. It is not even knowing what state you are in. But in case of level 1, we acknowledge, but then it does not do anything. Like, it just responds with a something like predefined something, but it does not perform any adaptations, right? So we've already gone through this. So level 1 is basically it acknowledges or recognizes the need for adaptation, that you sound frustrated, how can I help you, but it's not going to do anything on their own, right? So it does not perform any adaptation on their own. uh, Next question is, what metrics or indicators might trigger the recognition of a need for adaptation in a level 1 system? So let's say changes in user's voice or other modalities indicating negative emotional states, no alterations in system behavior based on emotional cues, no, predefined interaction scripts, no consideration for emotional states, no. So the correct answer is A, because level 1 adaptation, we know that it senses, recognizes the need of adaptation, involves monitoring using various indicators related to user's emotional state. Then how does the chatbot get to know, like, or if there is a voice assistant like Alexa or so how do they know that something is wrong, or I need to change, or something is required, the person is sad or whatever? So whatever sensor you are using, basically any kind of, let's say there's a microphone, then uses tone, voice tone. Even if it is a facial expression thing, then you might see that there is no smile on a person's face. Then you observe the speech patterns, facial expressions, or other modalities, whatever is there. It can provide valuable cues about the emotional states. So, a sudden shift from voice pitch to a slower speech rate might indicate sadness or frustration. Then the system needs to acknowledge that this change I have figured out, and now the like I need to um, respond accordingly. Although it does not respond accordingly, it just acknowledges the fact that there is something wrong or off, or how can I help, like it can just tell you, ask you. So the first option is correct. Then what distinguishes level 2 adaptation systems from lower levels of adaptation? So they rely solely on predefined scripts, they adapt based on random changes, they optimize user performance metrics on emotional states, they ignore the user's emotional cues. So another example to understand different levels of adaptation using a single kind of example. So let's say the virtual tutorial system is there and we want to assist the students in their studies. Okay, now it can capture such various facial expression, voice tone, physiological, etc. So in the case of level 0, whereas no adaptation is there, the virtual tutor may deliver pre-scripted lessons. which is usually the case. Let's say you're watching a video on YouTube, it's just playing on your screen, nothing is changing. ठीक है, it follows a fixed sequence of interactions regardless of whether the student is engaged, bothered, frustrated, bored, or excited. ठीक है, the system does not recognize the need of adaptation based on emotional cues, so no adaptation. Then comes level 1, which is the basic adaptation. Level 1, one system monitors the system's emotional states, but it cannot, may not recognize the system, मतलब way it does not respond accordingly, basically does not know how to respond effectively. So if student displays signs of frustration during a challenging problem, the system may continue with the same instructional approach, although it is knowing that the person is getting frustrated. So no adaptation, just acknowledgement. Then level 2 is advanced adaptation, so the pace might be lowered. Let's say if the tutor detects the student is feeling overwhelmed or demotivated, it can dynamically adjust its teaching approach to provide additional support or more personalized guidance. Let's say you are teaching vectors and the person seems very frustrated, so you can repeat the lecture, repeat the content, or maybe teach at a slower pace. So other actions or responses can include simplifying explanations. You can explain again, or offer encouragement that you can do it, don't worry, it is easy, once you practice the questions you will be able to solve this. Or providing alternative learning resources, like let's say if the lecture is not intriguing, or you're feeling bored and you don't understand anything, then it can provide you with something different. So level 2 is uh, yeah, so this is not true about the level 2. They adapt based on random changes, no. They ignore usual, this is also wrong. They optimize performance based on emotional states, which is true. So which of the following is a characteristic of level 3 adaptation in affective computing? Level 3 adaptation is more on the real time aspect. So adapting only predefined behaviors, focusing on a single performance metric, adapting multiple tasks concurrently, ignoring user feedback. So we saw that in level 0 no adaptation, level 1 is just acknowledgement and no reaction, no response. Level 2 is optimizing or changing, adapting one task at a time. Then comes the level 3, which is adapting multiple tasks, basically. So it can the tutorial the tutor can change these three, let's say content, it can change or simplify the content. Teaching style, it can reduce the pace, lower the pace. And then feedback adaptation, also you can provide more of positive feedback and so on. So it the USP for level 3 is that it can adapt multiple things at a time according to the user's emotional state. Okay, which of the following statements are true? Level 4 adaptation involves the coordination of multiple independent agents or services to optimize user experience. In level 4 adaptation, communication between agents allows for collaborative adaptation. Level 4 adaptation focuses on adapting individual tasks independently without communication. So 3 is definitely wrong, because level 4 has this speciality where it involves the coordination of multiple agents, multiple independent agents, but then they're interacting with each other. So it involves, as I mentioned, it involves the coordination of multiple independent agents and services to optimize the user experience. This means that different agents collaborate and communicate to adapt to various aspects of the user experience. Um, so it does not focus on individual tasks independently. but it is more of a collaborative thing. Also, communication between agents follow different tasks, processes. It basically enables the agents to share information and coordinate their adaptive behaviors to achieve the desired user experience. So 1 and 2 are correct, but 3 is not. So 1 and 2. What are the two kinds of empathy with respect to how an empathizer responds to the user? So, cognitive and reactive, affective and proactive, cognitive and affective, parallel and reactive. So, this is parallel and parallel and reactive empathy are, we know where, I think this is also correct. So C option is also correct and D is also correct, but let's see. So parallel, we know parallel means to mirror the same emotion which the person is experiencing. Let's say I'm happy and I'm excited. I'm telling you about something that I achieved in today, let's say, and then the agent is, or the robot, let's say, it is also feeling the same emotion or reciprocating the same emotion. Same emotional experiences mirrored in or reflected in this other person or the agent. So that is called the parallel empathy. If a user expresses sadness, a system exhibiting parallel empathy, it might respond with a compassionate tone, sympathetic gestures, comforting words to match the user's emotional state. This mirroring, it helps. Then reactive. So reactive means that you are kind of trying to mend the things up, or you're trying to make the things okay. Okay, so we want to respond in such a way that we want to alleviate or address their emotional state. Let's say happiness. If the person is happy, you don't want to change the state, right? But if a person is sad, then you want to change it, you want to react to it. So if a person is happy, mostly we will use the parallel empathy. That means parallel, if it is a good emotion, good feeling, then you also want to experience the same feeling. But if it is a bad feeling, we want the other person to feel better. So we, if the person is sad or anxious, we won't be anxious or sad ourselves, but we will try to comfort them with good kind words, maybe a hug or anything like that is relevant. So if I, let's say if a user expresses frustration or anxiety, then the system, employing reactive empathy, it can respond with calming techniques, problem solving strategies, or uplifting messages to help the user to alleviate the negative emotions, and it wants to promote a more positive emotional state. So this is correct, although I think this is the C option is also correct only, cognitive and affective. But anyways, cognitive is more like a logical thing, and affective is just mirroring the emotion. So next question is, what can be the correct order of stages in case of an autonomous empathizer? So autonomous means automatic, right? And empathizer means some agent who is having the understanding of empathy or emotions. Now what can be the steps, the correct order? Understanding target's perspective of the emotion, detect the target's affective state, generate an empathetic response. So this is the first step, is to detect what the other person is feeling, right? Because that is where we decide how we will be responding to it. And also we want to understand the target's perspective of the emotion, like why is it happening, or what is the context or past experience, and specific triggers or reasons why the person is behaving that way or experiencing that emotion. According to that, then you get the context, then you have to generate an empathetic response in response to that emotion. So we want to acknowledge, validate, address the user's emotion differently. Now, just a diagram. So we have this. Firstly, we want to detect or observe the state, okay, the target state. Then we have this user's affective state. Then there is a perspective taking module in the robots. Like it also wants to think about it, like how to proceed further or so. So then it also the empathetic type determiner. Let's say the emotion is being the motion that is being expressed by the target is weak or normal, so we do not want to counter it, right? We do not want to counter it. So every uh, negative emotion, or if it is a very strong, even positive strong emotion, we want the person to calm down, right? It shouldn't be like very much excited and over excited, and we just want to bring everything to the neutral, more of a neutral or calm state. So here we determine which kind of empathy would be used. So parallel empathy in the case of any positive emotion or some weak emotion. If any kind of strong emotion is there or negative emotion in general is there, then we use the reactive empathy. So reactive is basically to counter the effect of the existing one. So the correct order becomes firstly detection, then we want to understand the perspective, and then we want to generate. So 213. Okay, what is the type of empathy which is used for subtle or positive emotions? Reactive, neutral, parallel, or emotional. So subtle means weak, right? So weak, any kind of weak emotion, negative or positive, or in general normal intensity, this is positive, that means we will use parallel empathy. So parallel, it helps to foster supportive and empathetic interaction. How is emotional security defined in the evaluation of the empathizer's responses? So the level of confidence and comfort felt by the user during interaction, the emotional state of the empathizer, the number of facial expressions displayed by the empathizer, the amount of time spent in interaction. So emotional security is basically when I'm talking to a system or an affective system and I am not feeling comfortable. I'm talking to a machine ultimately, and it might not behave in a more human way. So I might feel slightly uncomfortable. So how is that term, that emotional security, like how comfortable or how secure I feel when I'm talking to or interacting with a robot or any affective system. So the level of confidence and comfort experienced by the user during interaction with the system, this is called the emotional security. It reflects the user's perception of safety, trust, emotional well-being while engaging with the empathizer. Okay, let's say if it is high on the security side, like if you feel very secure, then even you will be able to express yourself. Let's say in the case of a virtual therapist, which is here to listen to your story, so you will be able to share your experiences or your stories better way, in a better way than if you don't feel that much comfortable. If you are insecure, then you might exhibit hesitancy, guardedness, or discomfort in there, if in your interaction with the system. So it helps us to build better system. Let's say we want to build systems which can provide higher emotional security. So the correct answer is the level of confidence and comfort felt by the user during the interaction. So uh, last question is, yeah. So which of the following can be the parameters for evaluating empathizers' target interactions? Social presence, engagement, accuracy, trust, recall, and precision. So first is social presence. Social presence is an important criteria, because you can judge how well the affective system is when it is having a more like better social presence. So basically this parameter extends assesses to the extent to which the empathizer is perceived as a social entity. Let's say there is a robot, uh, and you are five people interacting. Like, if you're also interacting with the robo in the same way you will interact with your friend, so it is considered more natural, like more comfortable and more social entity than just a computer based system. So the social presence is a metric. Then engagement is the level of user involvement, interest or interaction during the interaction with the empathizer. If the it is more like a robotic voice and everything, it seems so unnatural and it seems so mechanical, then you won't be happy interacting with it, and it won't give you that immersive experience. Then comes the trust part. Like, if you are telling your vulnerabilities to a therapist or virtual therapist, or if you're telling some very sensitive information about yourself, you're sharing that, then you want to trust the system as much as possible, because the more the user's confidence and reliability on the empathizer is there, it it can foster trust and credibility in its interactions, and it helps to develop a positive user relationship. Then comes accuracy, recall, and precision. These metrics are used in more like ML systems rather than these affective systems, because we are not classifying anything. We are not like we don't have any categories. It's more like a natural conversation, right? So these are not the right metrics for assessing the empathizer, how good the empathizer is performing. So, out of these options, the social presence is correct, engagement is correct, accuracy is not, trust is correct, and this is also not correct. So, 1, 2, and 4 options are correct. So, thank you for watching this video. And so basically, next session will be on 8th of April, and we will be covering the week 11's content in that. Thank you, and happy learning.